Is he looking for little? Is it like blocks?
Yeah, looks like
Oh, I have
it's
one
out.
of those blocks.
Very good. Who was your teacher last year? In Jersey? Oh, somebody in Jersey taught you something.
I said something third in my camera.
Did Bruce Springsteen guy? Did Bruce Springsteen
It looks like we're gonna have a test next Thursday. And it will be a test, so it's a pretty big one.
Whoa.
I had to do this.
Can you do this?
Yeah. Ax plus 2 bx plus 3 equals 7. Solve for x. So I like do like distribute this because they are just getting stuff out of line. Good still early.
Yeah. All right. Ooh, I gotta take, did you do attendance?
I get it.
I did not.
Yeah.
We're missing Zachary.
Zach.
Tell me
one more. Zane.
Zane.
Yeah.
Zach and Zane. The Z boys. Okay, we want to solve for a given variable like we just talked about. All right, think about formulas. You had a lot of formulas over the years. One of the formulas is D equals RT, distance equals rate times time. And formulas come up a ton in science. Can anybody think of any other formula you've used in math or science in the past? Okay. Oh, come on, Allie. A squared plus B squared equals C squared. Good old Pythagorean theorem. Okay. Volume equals length times width times height. Area equals length times width. Those are for rectangles and rectangular solids. So there's all kind of formulas out there. And so sometimes I want to take this formula, instead of putting it equal to C squared, I want to put it equal to A. Or I want to take this formula and get the W by itself. Or I want to take this formula and get the R by itself. Y equals mx plus b, what we had earlier, that's a common one for equations of lines. We're doing that a lot this year. Haven't really come into it yet, but we need to be able to move it around and say, all right, I want the x by itself, or I want the b by itself, or I want the m by itself. So that's kind of what we're doing today. A formula, okay, so fill this in, okay, is an equation that states a rule for a relationship among quantities, like the length and the width. We multiply those together to get area. The height, okay, we multiply those together. So we want to manipulate these formulas. I used this earlier in the formula D equals RT. D is isolated. You can rearrange a formula to isolate any variable by using inverse operations. Basically what we've been doing all along. This is called solving for a variable. Okay, so I believe you have this on your sheet, right? Locate the variable you're asked to solve for. We're going to do the opposite. So if they're adding something to it, we're going to subtract something. If they're multiplying it by something, we're going to divide it. That's basically everything we do with an equation. So we want to use the inverse operations to undo it. Get the variable you are solving for alone. That is our whole goal. All right, let's actually take a look at something. Now, here's what I'm going to do in the beginning here. Okay, I'm going to highlight, you circle, you do something, the variable we want to get by itself. And it says solve it for x. Well, get it by itself. When you want to get it by itself, you got to look at the equation in the equal sign. And what is on the same side as the x? So it's not by itself. Colin?
Y.
Y. What are we doing with this y? Is it being added, subtracted, multiplied, or divided?
Oh, it's been added.
It's added. So undo that, which means we subtract. So you subtract y, and anything I do on the left side, I got to do it on the right side. So write a minus y underneath there. This is where we write this line. Now, the whole reason is because y minus y is 0. It cancels it out. So now, what's the only thing left on that left-hand side? X. But now, what do I write on the other side? X equals what? Okay, x equals what? Alan? 15 minus y. That's our answer. Now that one was really just one step. Some are one step, some will be more. But we did our job. We got the x by itself. X is the same as 15 minus y. Before I knew x plus y equals 15, I wanted to rearrange things. So I need to be able to do that. All right, solve PQ equals x. I am solving for Q. I am solving for Q. Now you've got to be able to look at that and understand what's going on. What's happening between the P and the Q? Okay?
They're being multiplied.
They're being multiplied. If they're written right next to each other, they're being multiplied. The inverse of multiplication is what?
Division.
Division. So we want to divide. Well, how do we show division? I specifically told you this. You should do the line underneath. And I divide by whatever's multiplied by. So divide by P, divide by P. So all we write is Q equals X divided by P. Okay, so that one was one step. That one was one step. We just had to divide. All right, now this one isn't too bad. So 6 minus 4b equals 2t. All right, now put in that blank, put in that letter t, so you identify what you're solving for. All right, now how do I get the t by itself? Well, okay, Christian, what do you think?
Subtract 4b.
Okay, now here's where you got to take a look. Where's the t at? Is it on the right or the left?
Right.
It's on the right. So we don't mess with anything over here. The only thing that is with the t that I got to get rid of is the 2. Well, what's happening between the 2 and the t? They're being multiplied. What's the inverse of multiplication?
Division.
Division. So I'm going to divide. Now, if I got more than one, so divide by 2. If you got more than one term, here's what we're going to do. Divide the whole thing by 2. So I get 6 minus 4b divided by 2 equals t. Now, we always want to write the t first. So I'm going to flip this around. Okay, now that's okay, but there's sometimes we can write it a better way. Here's what we want to do is once we divide by 2, we can split this apart and divide them both by 2. So this becomes 6 divided by 2 minus 4b divided by 2. Well, what's 6 divided by 2? 3. And what's 4 divided by 2? That's going to be our final answer for this case. Now, sometimes you'll be able to jump straight to there, divided by 2. If you understand that, that's fine. But sometimes you're going to need to split it apart. And if it doesn't divide evenly, we just leave it as a fraction. And we'll cover a couple of those. All right. Solve this one for B. Solve this one for B. All right, where's the B at? The B's on the right-hand side. This is A times B times C. And it doesn't really matter what order. It doesn't matter whether it was A, B, and C or B, A, and C. If I'm solving for B, all of those are being multiplied. So you can divide by more than one thing. So what are the 2 things we need to divide by? Huh?
A and C.
A and C. So you can just do this right like this. A and C. A and C. Those cancel and you're just left with B equals Y divided by AC. So B equals Y divided by AC. And then rewrite it, put the B first. Okay, put the B first. Okay. All right, so you gotta look, do I need to multiply, divide, do you need to add or subtract? How do I get those things along? Connor?
I should say, for, problem C, I was kind of all over the place in that one.
Okay,
A little confused.
well, what was your first thoughts?
I got past divided by 2 and then it kind of went blank.
Okay, so we divided by 2, right?
Yeah.
And so I get 6 minus 4b divided by 2 equals t. Here's what you want to do at this point. We want to divide each piece by 2. And so what you can do, and then sometimes we'll get to the point, I want to do that first, but sometimes you can do it like this. All right? What's 6 divided by 2?
3.
3. What's 4 divided by 2?
2.
So we can do it that way. Okay, so you can just divide each piece by 2 if that helps.
Okay.
All right? Now, and we do that way, especially if it's a number, and I know it might divide into those other numbers.
Okay, that's also why, like, we say divide the whole side by 2. So everything over here, not just one term, not just where the variable is, everything is getting divided by 2.
For that. Okay, flip it over in the back. Flip it over in the back. Okay, solve this for y. Make sure you put the y in there. All right, now, think about this one here. Think about this one here. Adding a little bit of a layer. All right, how do I get so Connor, go ahead, since you had questions here. What do you think we do for this one?
We're going to divide 2x or subtract.
You got to subtract it. Okay, if this is separated by a plus or a minus, then this is not multiplying by the y is being multiplied by the 7. That's the last thing you want to do is mess with that 7. We got to get rid of the 2x by subtracting 2x. So put minus 2x, put minus 2x, and then I get 7y equals. All right, what do I write on that other side? And I always say write it like you read it. What should I write, Christian?
7y equals 14 minus 2.
Yep, just write it straight down. You cannot make this, do not try to make this 12x because this 14 does not have an x. You can only combine them if they both have the same variable. So the only thing you can do is write 14 minus 2x. All right, now we want to divide everything by 7. So maybe it might be better if you divide each piece by 7. Well, actually, I want to do it in 2 steps. Okay, so I'm going to divide everything by 7, which gives me 14 minus 2x over 7. If this is a constant, then I want to break it apart and see if I can simplify it. Okay? This is a constant. So now, this becomes 14 divided by 7 minus 2x divided by 7. Now, what is 14 divided by 7? 2. All right, now here's where you got to watch. Does 7 go into 2 evenly? If you did 2, it's going to give you a decimal, right? Leave it just like it is. Leave it as a fraction. So write minus 2/7 or 2x over 7, or that's the same as 2/7 x. Either way. Mr. Schler, help me out if there's a better way to explain it.
The only way here, we are not teaching you anything new today. All the rules that we've taught you so far, we're applying the same stuff here. Okay, it looks a little bit different, but all the rules are the same. The biggest issue you guys are going to have, besides with dividing that whole side, is going to be what Mr. Dila said earlier. Scroll up just a little bit, Mr. Dila. Is this first step here? I'm telling you, 14 minus 2x, and you guys are going to want to put 12x. That is the one that you guys are going to screw up because you won't know how to combine those. You want to combine them, but we've been telling you since the first week of school, you can't combine them. They're not like terms, so you just got to rewrite it. Okay?
Okay, right here too. This answer is fine, but sometimes you'll see it written with this x term first, and that's how we're going to want you to eventually write it. We'll accept this for now, but if somebody gave me this as an answer, that's the same thing, and that's okay.
Grant said earlier that we use this to, with the y equals mx plus b, we use it to graph. That's why, okay? That's gonna help you as we move on.
Yep, and we'll put it in that way, but we're not gonna be too concerned. All right, F, solve this one here, for X. Solve that for X. So you get 3x plus 18y equals negative 12. Then let's do this together. Make sure we know. All right. What do you think first instinct to do? Okay, first instinct to do. I didn't call it a couple other people. Joe? I haven't called it. Say that again?
Minus 18y.
Minus 18y. That is correct. So we want to subtract 18y. All right, now tell me what to write, though. Okay, Colin?
3x equals negative 12 minus 18y.
3x equals negative 12 minus 18y. Good. All right, Hanan, what do you think we do now? Yep, divide 3, divide 3. Now, if you can take a look and you know it goes into them, you can go ahead and divide it without writing it down again. Does negative 12 go into 3? Or 3 go into negative 12? Yeah. Negative 4, right? And what about negative 18 divided by 3? What does that give us?
Negative 6.
Negative 6. So that's going to be our answer. Now, the only other way you could write it is if you want to, you could flip and write. Usually we write the variable first, and you can put negative 6y minus 4. At this point, we take either one. Okay, we take either one for that. So that is just taking an equation, solving it for a variable. Now, we got to give you scenarios where you got to read through it because you're going to see these on like the end of course test. They will give you some additional information. Some of this information might be distracting information that you don't need. Some of it is information you do need. So you got to be able to decipher the wording of the problem. So they're going to give us a formula. The formula for an object's final velocity is F equals I minus GT, where I is the object's initial velocity, G is the acceleration due to gravity, and T is time. Solve for I. They're just giving you all this information. Really, the only thing it says is solve for I. Okay? It's great. We know G is acceleration. We know great is T is time. They're just justifying all the variables. Just solve for I. Well, what do I do to solve for I? I got to move the GT. Okay, so Christian? Plus GT. So this one is really not that difficult once you get past everything. Now, here's how you write it. F plus GT equals I. F plus GT equals I. All right? And then you're done. Now, I would prefer you to write the I first and flip the order because normally that's how it's going to be done. Okay? All right, I'm not going to worry about this second one or example 3. Let's go to that last one. All right, take a second. If you think you know how to do it, do it. If you're a little confused, we'll do it together. Because they're asking us to do a couple steps here. Okay, first thing, solve it for T. All right, well, Caitlin, what do you think? So do you know how, like D equals RT, any ideas on how to solve that for T?
Minus RT.
Well,
Or divided.
divided by what? Now, since we're solving for T, this is R times T, we want divided by.
R by T.
Divided by, and this might have been what you were saying, divided by R.
Oh, yeah.
Divided by R. That gives me D divided by R equals T. And like I said, I like to write the T first. So that one is just one step. That one is just one step. So T equals D over R, D divided by R. Now they give you a condition. They say, all right, find the time in hours it would take Ernst Van Dyke to travel 26.2 miles if his average speed was 18 miles per hour. Well, the 26.2 is the distance, so that goes in for D. The speed is your rate, that's 18. So figure this out, do 26.2 divided by 18, and go ahead and do that on your calculator. Now give us the time it takes. And that is, all right, I'm gonna round that to the nearest 10th. Should be, well, the nearest hundredths. It's 1.45 repeating, right? Is that what you got? All right, if I'm going to the nearest hundredth, that second spot, I'm gonna make it T equals 1.46 hours. Okay, 1.46 hours. Okay, for that. All right, this takes a little bit of time, but we're gonna hand out a worksheet. All right, those of you who did not turn in the assignment from yesterday, that's your first responsibility to do that now. Okay, so I know there's a few of you, Evan, Christian, Austin, Joe, start that now. And then that doesn't excuse you from this. Maybe I need to work on that. Pull out your, open that up. What's that? No, it's on a, it's just on the modules.
Thank you.
Go ahead.